Hello guys and welcome to the third project of NAND2TETRIS. I am Sarvesh and we are here to learn about all these things. First of all, we will learn about single bit register, then 16-bit register, then memory banks, RAM 8, RAM 16, RAM 64, and then program counter. So starting with single bit register, what is single bit register? It takes one input, output, and it writes something. So we will code for single bit register and I will show you how to code it. So we will follow our basic format, chip. After chip we will write the file name, what will be the input, in, and load. Output will be out. We will write parts. What are the parts? We will use mux. A will be difference out, B equals in, selection equals to load, out equals to mux out. In equals mux out, out equals yeah. Then we will OR it. A equals to dff out, B equals out, and output is out. We are saving it, and I have already opened this hardware simulator. We will file, load chip, bit.htl. We will load chip. We will load the script, bit.tst. We will set it to fast and run. It is checking the test case and hopefully it will be successful. Let's see. Yeah, end of the script, comparison ended successfully. So we have successfully written the code. Now let's move on to the second thing, register. What are registers? Registers are a combination of single bit registers. So this is 4-bit register. Here we have implemented 16-bit register. I have shown the diagram of 4-bit register because it will be easier to understand. So it takes input, it has reset, it has clock, and these are the outputs, Q0, Q1, Q2, Q3. And so here is our code for 16-bit register. Chip register, we have followed the same format. Input will be in of 16, this will be array, and load, output will be of array of 16. This is a 16-bit register, so input and output will be of array of 16. Parts, these are the parts. This will be 16. We have combined the 16 registers, each of 1 bit. So we are loading input of in of 0, load equals to load, output of out of 0, and in of I. We are following this general format, in equals to in of I, load equals to load, and out equals to out of I. So as you have understood the code, now let's check it whether it's correct. So register.htl, chip, load the script and run it. So it's checking, pretty long test cases. In a similar way you can also, okay, this comparison ended successfully. I was saying that in a similar way you can also implement this 64-bit register, or if you want 128-bit register, and so on. Now moving on to RAM 8, I have already written the code here. Input is RAM. Okay, I have, yeah, this is program counter, fine. RAM 8 input is 16, array of 16, load, address 3, out of 16. What are the parts? Demux 8-way, 8-way demux is there. Input is load, selection equals to address, A equals load of A, B equals load of B, and so on. We are using 8 registers here. Input is in, load of A, we are loading A, B, C, D, E, F, G, H, and we are outputting A, B, C, D, E, F, G, H, and then we are combining all of it using mux 8 to 16, and this is the output. So now let's run our code. Chip RAM8. Oh. RAM8.htl, we have loaded the chip. RAM8.tst, load script, and running it fully. In a similar way, you can implement RAM 64, RAM 128, anything. Just increase these things. Registers, number of registers you need to increase, and the variables, number of variables will be increased. Here there are only 8 variables and 8 registers. If you want to implement for 64-bit, you will have to use 64 variables and 64 number of registers. And so we have comparison ended successfully. Our code is very much correct. So yeah, this is 64. What we have done is we have used an array. We have used RAM8 in place of register, 1-bit register. We have used RAM8 and we have written this 8 times. So 8 into 8, it becomes 64-bit RAM. It has been done. Now if you want to do for 128-bit, you will have to write RAM 64 2 times, because 64 into 2, 128, and it will be fine. Now let's move on to program counter. What is program counter, guys? This is the diagram of program counter. Okay, so this is the code. Input is, we have taken input array of 16. We are loading. Increment INC, we have already seen the code of INC in the previous video, NAND2TETRIS Project 2, and it is reset. Output is also array of 16, and these are the parts. Increment of 16 in registration. Register will give the output, so reg out equals to +1. This is program counter, so it will count, so that's why it is getting +1. Mux, we have used 3 mux here. A false, B +1, select equals to increment, out equals to increment count. So this is OR, A load, B reset, out equals to load or reset. And here again we have used registers, and for output we are using an OR gate of 16. So it will take 16 inputs and will throw 1 output. So as you have understood the code, let's check whether our code is correct or not. pc.htl, we are loading the chip. pc.tst, loading the script and running it. Short test case, and it's successful. So that's all for this video, guys. Comment if you want some clarification for the codes, and that's all from my side. Thank you.